Okay, guys, so I'm going to go through and explain the Chapter 4 review. And I'm not going to write it so that I can go a little bit more quickly since there isn't much math involved. All right, so the first question, the plum pudding model proposed that negatively charged electrons were in a sphere of positive charge. And that's true. Remember, the plum pudding model is the same thing as the chocolate chip model with, if you remember, the circle, the actual dough being the positive charge and the chocolate chips being the negatively charged particles. So that is a true statement. Number two, Thomson was the one who came up with that plum pudding model, and he did not discover protons. He discovered electrons, the negatively charged subatomic particle. So that was false. The gold foil experiment proved that large regions of the atom consisted of empty space. That is true. This was conducted by Rutherford. So if you look at the nice little diagram that I drew you, most of the atom is empty space except for a couple of electrons. Then you have a very dense, positively charged nucleus. And so what he actually found was that most of the alpha particles, which were positively charged particles, passed through the atom. Okay. And what he wasn't expecting, he was expecting a little bit of deflection as it hit positively charged particles. But what he saw was a huge deflection, like what I just showed there. And so what that was showing him was that there was this really concentrated, positively charged nucleus. And so that was his discovery, that you have a nucleus that's really concentrated, has a large mass, but then the rest of the cell is empty space with electrons scattered around it, but most of the space is actually just empty. All right, 4, a positive charge attracts a negative charge and repels other positive charges. That's true. Remember, positive attracts negative, and positive repels positive, while negative repels negative. All right, the charges on electrons and neutrons cancel each other out to give neutral atoms. Neutrons have no charge. Electrons, which are negatively charged, cancel out protons, which are positively charged. So that was false. Number 6, an atom containing 8 protons, 9 neutrons, and 8 electrons would be considered charge neutral. Absolutely. 8, that would be an 8 plus charge from 8 protons. 8 minus, 8 plus, and 8 minus cancel each other out, so that would be neutral. True. An atom containing 8 protons, 9 neutrons, and 8 electrons would have a mass number of 16. Now, remember, you get mass number from taking protons and adding neutrons. So 8 plus 9, that's your mass number, protons plus neutrons, is not 16, it is 17, so that was false. Make sure, guys, you're correcting these because that's what you need to do on your test. All carbon atoms have exactly 6 protons. That's true. Even if they are an ion, in an ion, you're changing the number of electrons. In a neutron, in an isotope, you're changing the number of neutrons. You never change the number of protons. 9, the atomic number of nitrogen is not 14.01. That is the average atomic mass. You couldn't change this and write mass number because that would be just 14. That would be one of the many mass numbers it could have if it were an isotope. So instead, I'm just going to change the 14.01 and make it 7. So that was false. Mendeleev's early periodic table predicted the existence of elements that had not been discovered. That was true. Other things to remember about Mendeleev, he organized it based on average atomic mass. So he was organizing the elements based on mass. He noticed that there were trends within the groups like what we see today. But unlike what Mendeleev organized it based on, which was mass, it's now organized based on atomic number. Group 2A elements are called not alkali metals. That's group 1, alkaline earth metals. Metals have a negative charge because they lose electrons. No, they have a positive charge. When you lose an electron, you lose a negative. Minus, minus, that becomes positive. Magnesium receives a +2 charge by gaining 2 protons. Guys, if magnesium gained 2 protons, it would become silicon. So it cannot gain 2 protons. It would not become an ion. It would become a totally different element. Therefore, it can only lose 2 electrons to become positively charged. Multiple choice. Which statement below accurately describes the contributions of Dalton? Dalton, guys, was the atomic theory, the modern atomic theory. So that was C. All right. Modern periodic table would have been Mendeleev. Existence of electrons was Thomson. Ancient Greek philosopher, we didn't go over that. All right. 15, which is not part of Dalton's atomic theory. Okay, so in my mind, if I have trouble with multiple choice, what I do is I list everything that Dalton did. So number 1, I know that he said that atoms were indivisible or indestructible. Number 2, that atoms of the same element have the same mass. And he also said that atoms combine together in a whole number ratio, small whole number ratio, to make compounds. So A is true, B is true, C is true. D was not included in that list, right? Because the person who discovered that was Rutherford. 16, the atomic mass unit is defined as, this was just a definition I gave you guys, just be familiar with it, 1/2 the mass of carbon. Okay. 17, which of the following statements about the nature of electrical charge is false? So electrical charge is a fundamental property of protons and electrons. Yes, protons positive, electrons negative. Positive and negative electrical charges attract each other. Yes, we said that before. Positive, positive, or negative, negative repel each other. Yes, we said that before. Positive and negative charges cancel each other so that a proton and electron, when paired, are charged neutral. Yes, that is true. So all of the statements are true. The answer is E. 18, what is the atomic symbol for silver? Guys, that's just looking at the periodic table. Look at the periodic table at the very bottom of the last page. That's what you'll be given on your test with nothing else on it. So make sure you can find silver. That's B. It's a transition metal with an atomic number of 47. 19, tin is A, so it's SN. 20, which of the following is not a correct name symbol? Beryllium, guys, is Be. Magnesium, Mg. Iron is Fe, ferrous. So C is wrong. 21, metals are located where on the periodic table? I had an argument about this with my 6th period, so I'll go through this. When we're talking about left side versus right side, we're talking about on the left side of the ladder or on the right side of the ladder. Okay, so all of the elements on the left side of the ladder, except for hydrogen, are metals. If you just say the middle, you're just talking about transition metals and you're leaving out your alkali metals and your alkaline earth metals. So don't leave them out. A is the correct answer. 22, group 1, this is just definitions, guys. They're called your alkali metals. Group 7 are your halogens. Group 8 are your noble gases. And group 2A are called your alkaline earth metals. 26, all of the following statements are different elements, about different elements are true except barium. Barium is an alkaline earth metal. It's in group 2. Manganese, it is a transition metal. C, sulfur is not a metalloid. It is a non-metal. Okay. D, krypton, it is a noble gas because it's in group 8. So C is false. Ions are formed when atoms, you can only lose electrons, guys. Electrons and protons are the only thing with charge, the only subatomic particle that has charge. Electrons are the only thing that you can gain or lose. Protons would give you a totally new element. When an atom gains an electron, right, you now have a negative charge. Something with a negative charge is called an anion. If you lost an electron, it would be called a cation. Which is the correct formula for potassium ion with 18 electrons? Remember, the atomic number of potassium is 19, which means it has 19 protons. So 19 minus 18, because that's the formula for charge, is +1. So it's B. How many electrons are in Br? The answer is D, 36, because the number of protons in Br is 35. So 35 minus 36 is -1. So I'm still using that protons minus electrons equals my charge formula. Isotopes are, just definition, guys, atoms of the same element that have different numbers of neutrons. The only other answer that makes sense is C, atoms of the same element that have different numbers of electrons. That's the definition for ions. Okay, the other two make no sense at all. The nucleus of an atom contains mainly protons and neutrons. Because your electrons are outside of your nucleus, we say they are, in quotes, orbiting your nucleus. We will explain later on in the year why that's actually false. 33, how many neutrons are in neon 22? This is your mass number. The atomic number of neon is 10, so 22 minus my number of protons, which is 10, would be 12, because protons 10 plus I don't know what equals 22, that would be 12. All right, an atom that has the same number of neutrons, guys, you've got to subtract them. So 138 minus 56, which is 82. So find out which other ones have 82 neutrons. And when you do the math, you'll find that D is your answer. 33, if you look here, because the most abundant isotope is isotope 20, okay, what that's telling you is that its mass number is going to be closest to 20. Okay, so if it were 50-50, right, then that would be exactly 19 because it would be halfway in between. But since it's closer, it's 60%, it's going to be closer to 20. So the atomic mass would be closer to 20 than 18. So make sure you're comfortable with that concept with abundance, that if it's the highest percent, that's what your average atomic mass is going to be closest to. 34, given the molecular mass. So since it's 79.9, guys, if you're given all of these, you would expect that the isotope with greatest abundance would be Br 80 because 79.90 is closest to 80. Which of the following are isotopes of each other? Remember, isotopes, different number of neutrons, same number of protons. So A, these have different number of protons, that doesn't work. These have the same number of protons, but different number of neutrons because they have different mass numbers. So that works. Let's check the other ones. Different number of protons, so that doesn't work. Okay, same number of protons, but same number of neutrons because they have the same mass number. These are ions of each other. Okay, so that's not what I'm asking. I'm asking for B. All right. So here's my answer for 36, guys. I'll go through it quickly to explain. The 4 up top is my mass number. The 2 on bottom is my atomic number. Okay, and He is my symbol. Notice I have no charge. Okay, atomic number is 2. 4 is my mass number. 2 is protons because you get protons directly from atomic number. I have 2 electrons because it's neutral, so I've got to have the same number of protons and the same number of electrons. Since my mass number is 4, 2 plus 2 equals 4. Okay? And then it's an atom because it's not an ion. Okay? All right, for this one, atomic number is 27. That tells me it's cobalt. I know its mass number is 59. And I know it has 25 electrons. So 27 protons minus electrons, 27 minus 25 is plus 2. So that's my symbol. I need to see all of that on the test. Now, if I know my mass number is 59 and I've got 27 protons, I just subtract and I get 32 for my neutrons. Since it has a positive charge, I call it a cation. No cations, cation. All right, atomic number 85, I'm getting all of this from here. Mass number 210, protons 85. Electrons, since I've got one more, I've got a 1 minus charge, 85 minus what equals -1, it would be 86. Guys, if you need to do the algebra for that to get that, that's fine. Make sure you're doing it though and not just guessing. Now, mass number is protons plus neutrons. So I've got 85 protons, a mass number of 210. So 210 minus 85, 125. Okay, and it's an anion because it has a -1 charge. All right, boron, atomic number 5, mass number 11 because it had 5 protons, 6 neutrons. Therefore, its mass number is 11. Since it has 2 electrons and 5 protons, 5 minus 2 is +3. So there's my charge, and it's a cation. Here, atomic numbers 37, 85, 37 for protons. Okay, I'm hoping we're getting it at this point. Protons minus electrons is +1. So 37 minus 36 is +1. Neutrons plus protons gives me my mass number. So 37 plus 48 gives me 85. And it's a cation because it's a +1 charge. Last one. Since protons are 15, my atomic number is 15. 31 for mass number because 15 plus 18. That's wrong. Oh, sorry. 15. Sorry, my brain. 15 plus 16 is 31. Okay, I've got 15 protons and 18 electrons, so 15 minus 18 is -3. There's my -3 charge, and since it's in a negative charge, it's an anion. All right, guys, remember to look at your table in order to determine whether something's a metal, a metalloid, or a non-metal. Okay, so it should be really nice and simple. You should have all of those colored in, and you need to memorize which ones are metalloids. They just go along the ladder, so be able to identify which ones are metalloids, which ones are metals, and you'll totally be able to do that. I'll show you guys at my drawing right at the end if you stick with me. Okay, beryllium, because it's on the left side of the ladder, is a metal. Silicon is a metalloid. Hydrogen is your exception. It's a non-metal. Bromine is a non-metal. Antimony is a metalloid, and tungsten is a metal. It's a transition metal. Now, metals lose electrons. Non-metals tend to gain electrons, except for hydrogen, which is a funky exception. So look out if I include this one in. Okay, and then metals lose. So metals lose electrons, non-metals gain electrons. Last one. I tell you gallium has a mass number of 69, and this one has a mass number 71. So this is the percent composition. I need to move my decimal place over 2 places to make it a decimal. So it's going to be 69 times its percent abundance, which is 0.601, plus 71 times 0.3989. Now, I find this answer, this is my unrounded answer. Remember to add AMU because those are my units. Okay. Now, this, because I'm multiplying, I use my fewest number of sig figs. This has 2 sig figs, this has 4 sig figs. All right, so my answer, this is going to be 41. When I multiply these together, I need to round it so it only has 2 sig figs. That would be 41. When I do 71 times this, it needs, again, 2 sig figs, so it would be 28. Okay, so obviously I'm not doing that in my final answer. I'm just noting this because when I do my final step to find out rounding, I need to add 41 and 28 mentally, because what I'm doing is finding what is the fewest number of decimal places. This has 0, this has 0, therefore I need to round this final answer so it has 0 decimal places. So 70 AMU. Again, this has a significant amount of rounding to get to 70 AMU. So make sure you show this answer and that answer. Okay, and guys, I'm just going to leave this here. I'm not going to talk about it, but this is a nice review of all the concepts, showing you each of the group names and counting them, and showing you charges. So +1, +2, like I talked about in class, +3, ± 4, -3, -2, -1, 0 with all of the names. Remembering the fact that 1, 2, 3, 4, 5, 6, 7, 8 are your main group, and these are your transition metals. Okay, I will post on the portal right underneath the periodic table since I'm out of time.